Warminjaka Warrangi Narap Beek. Welcome to Warrangi, land and country. Firstly, I'd like to acknowledge that we're holding this meeting on the lands of the Warrangi people, who managed this country for many tens of thousands of years. And I give my respects to their elders, past, present, and emerging. I'd also like to welcome anybody from other mobs around the country. I'm Rob Gardner, and I help organise these meetings for the ATA with Chris Moss down the front here. I'd also like to thank Melbourne RMIT and the SPI in particular for providing us with this lecture theatre tonight. And you'll hear a bit more from Trivess in a minute. I think we've got quite a few new people to ATA tonight. So briefly, ATA was formed in 1980. We have 6,700 odd members, and we've covered sustainability in all its forms. So you probably best know us for two magazines, Renew and Sanctuary, but also maybe from Sustainability Day, the Electric Vehicle Festivals, Speed Date and Architect, and also our advisory services, which are available to members, which I'd recommend. And our research and lobbying facilities. So we have quite a range. Donna will be telling you a bit more about that later tonight as well. If you have any ideas or want to help in any way, we'd be delighted to talk to you afterwards. So tonight we are very honoured to have Alan Pears with us. But first we're going to have a brief introduction on SPI from Trivess. Then Alan Pears will talk, and then Donna will come in at the end to talk a bit about ATA's future and new developments. I'll briefly mention Alan hardly needs any introduction at all. He is probably one of the most outstanding people in the sustainability field, not just in Australia, but well regarded around the world, and is done so much in energy and climate research. But now I'll pass over to Trivess.
Thanks, everyone. Hard act to precede Alan over there, but I'll just take this opportunity to welcome you all to RMIT on behalf of the Sustainable Building Innovation Laboratory, which is a research group which sits within the School of Property Construction and Project Management here. My name is Trivess Moore. I'm a lecturer in the SPI Lab, and my personal interest is around sustainable housing, so looking forward to hearing what Alan has to say later on today. So the mission of the SPI Lab is to accelerate the shift towards sustainable buildings, and that's not just residential, but all types of buildings, through the production and dissemination of high quality research and education. We've been together as a group now for a number of years and have a number of small and larger projects with a range of different clients around the country, from state government through to federal government as well as industry. So we have a range of people in our group who each have different strengths. We have architects, we've got engineers, we've got scientists, and so forth. And I think that's one of our strengths, that we bring together this diverse team together to work on the challenges around sustainable buildings. So the four kind of core areas that we do research into are building energy efficiency and environmental performance, sustainability education for the building industry, outdoor and indoor environment, and built environment design, policy and regulation. And there's a number of our projects which are listed on our website if you're interested in finding out more about those, as well as the research outputs from them. I'll just quickly go through a couple of our current and previous projects here. This is one of our current ones, the Citizen Science Project, and it's all about how do we use citizens to engage and improve our science and data collection. And in this particular case, we're looking at microclimates in different locations around the country. So this is a multi-year project. It's heading towards the halfway point. And what it's doing is it's working with more than 12,000 local community members across 22 councils around Australia. So it's looking at trying to measure the heat the urban heat island effect, looking at things like overheating and local climate change. And it's using citizens to collect that data and to make recordings about that data along the way. And it's aiming to assist policymakers to be able to help improve urban development and addressing things like health and energy needs as well. The second one here is another new project. It was from the Victorian Climate Change Initiative grant, and again, this is a multi-year project. And what this one is doing is looking at how we can improve the indoor air quality for vulnerable populations. And in particular, this is looking at primary school students as well as aged care facilities. So it's looking at, I guess, the two extremes of vulnerability there. And it's testing an indoor air quality machine here, you can see it there, and it's testing before and after outcomes across a range of metrics, including things such as changes to health, learning rates, particularly of the students, more so than the aged care patients, and looking at things like the financial changes and the improved sustainability performance overall. And the aim is that we can try and inform more sustainable development in these particularly vulnerable communities moving forward. On the housing side of things, we're talking about housing today, the Nicholson Apartments, which some people might know in East Coburg, modular construction at the time was trying to include a number of different innovations. So we have evaluated this building over a number of years in terms of things such as resource consumption, thermal analysis, as well as engaging with the occupants. How have they been using these buildings? How have they found it? How have they interacted and engaged with those innovations of the building? And there were some interesting outcomes there in terms of the building performing as expected, but some of the challenges around the sustainability elements that they tried to include in the building there. And just the final one I'll talk about here before handing over to Alan is a project where we looked at some housing for the Department of Health and Human Services here in Victoria, who built 4 9-star houses out in Horsham, and we evaluated these over a 3-year period and compared them to their standard housing stock that they rolled out. So they were interested to know what the benefits were going to be of improving their housing quality from a sustainability perspective. And we found a number of different benefits, including improved health outcomes, improved financial outcomes, and improved thermal comfort outcomes. And you probably can't see it here, but the solid line in this graph down below is the outside temperature in the middle of a heat wave, and it was getting up to 43 degrees there on 2 consecutive days. The dotted lines are their standard housing, and you can see the temperature kind of tracks the outdoor temperature. The solid lines down the bottom are the 9-star houses without air conditioning. So for the department, it was really exciting for them to be able to see that what they were trying to do was kind of working in practice. So now they've been able to design and deliver housing that didn't need air conditioning. That then opens up a range of other benefits for not only them, but the low-income households who are in there. I'm just going to finish by touching on an event that we have coming up in December. It's the ASA Conference, and it is all around meeting the challenge of higher density living in the urban environment. And we've got a number of key speakers, as you can see here. So if you are interested in that conference, please do go to the website and have a look or talk to us afterwards. But now, time for the star of the show.
I'm feeling quite intimidated. I didn't expect lots of people. So, there you go. I'm used to being ignored. That's how it goes, isn't it? Anyway, well, thank you all for coming along, and I hope you find it useful and interesting. And I hope the text on my slides is not too small for all of those of you up the back. You can possibly move closer to the front. Also, one thing is that we are recording this, hopefully, and Chris is doing the backup recording. So apparently this will be available on the ATA website in all its glory. So there we go. Okay, so what I was going to do was talk a little bit at first about some of the lessons that I seem to have picked up as I've swanned around the Asia Pacific over a 2 or 3 years with the APEC Low Carbon Model Towns program, visiting about 15 or 20 cities and listening and talking about what they're doing in terms of trying to reduce carbon emissions. And also I had some thoughts about where things might go in terms of the kinds of housing that maybe we could and should have. So some of this might be a bit nerdy, and some of it is sort of testing you out to see whether I really am crazy or not. So we'll see how that goes. Also, what we're going to do in terms of format is that I'll talk for a while and then hand over to Donna, who has some very exciting news from ATA, and then after that we'll just have Q&A and see where it goes. Okay, that's the theory. Right, now I'll use that. Yes. Okay. I'm a bit concerned that the print may be a bit small for people, so I'm sorry about that, but you only just have to listen to what I'm saying, and you can read the things later on if you want. Okay, so some of these slides are from the UK and Paris and places like that. So the top picture is my west-facing hotel room in Manchester, and it was really good that I was out doing touristy things between 2 o'clock in the afternoon and 7 o'clock at night, because the room was incredibly hot during that period, despite the air conditioning. The slide on the side nearest me shows the sophisticated heat dumping system of a hydronic heating system, which was on the window side of the curtain, making sure we got the area next to the glazing as hot as possible. The thermometer, it's actually an old Energy Victoria thermometer. You can't get them anymore. Anyway, you know, of course it takes people like me to carry a thermometer to Paris, but there you go. So I had this really nice room on the top floor with a balcony, and it was 35 degrees inside the room, and I thought, oh, maybe I haven't turned the air conditioning on before I came, so I stuck the thermometer in the outlet of the air conditioner, and the air coming into the room from the air conditioning was 32 degrees. So I took the photograph downstairs as evidence and managed to go to a lower floor, because it was pretty obvious that whoever built this fairly modern building had not thought to insulate the roof. So there you go. We're not alone with non-compliance. So, and the last one is just, I had so much trouble with all the showers above baths, because the mixer tap, first of all, always wastes lots of water, because you're getting a mixture of cold and what should be hot water coming through until the hot water does finally come. But also they have these button things so that you get the shower, not the bath running, and I just kept not turning on the shower hard enough to keep the water coming out the top end. So these are the kinds of challenges for, you know, the naive Australian traveller as you go around. Oops, oh, that doesn't work. That's because I've got that button. Okay, so what were some of the lessons I got from tropical climates? Well, first of all, really, lots of crude and leaky buildings, because of course they design them to be ventilated when it's not too bad. So when it's 40 degrees or 35 and 90% humidity, they don't work very well. Lots of air conditioners and things with clogged heat exchangers, corroded heat exchangers, leaky refrigerant. But also an emerging need for refuges from the heat. And it was interesting in Jakarta, because we actually met with people who ran a shopping mall. And they explained to us that they saw one of its roles as being a place where people would come for refuge. So they ran, you know, handicraft things for the elderly and, you know, things for kids to do and all sorts of stuff. It was quite interesting to see how socially focused they were. I think they probably made lots of money selling lots of cold drinks too, but, you know, that's how it was. I think, you know, and as climate change keeps coming through, personal cooling, you know, whoever comes up with a nice flexible jacket that cools, I think will be making a lot of money. The pollution was just enormous, and obviously the health impacts from the pollution, in particular caused by crude cooking technologies. And of course, you know, it's widely recognised that women and children are the victims of the indoor air pollution from a lot of this cooking equipment. And there was certainly plenty of it. Oh, extend shutdown. Does anyone have a good idea what we do with that? Oh, I pressed the button. It went away. Right, oh, okay. There you go. It's a touchscreen. Hey, a modern technology RMIT has. There you go. Yeah, so also just the weather is getting hotter and hotter and more humid and more erratic. So, for example, in the Philippines, the tour guide, who knew nothing about where I was from, was sort of saying, oh yeah, our farmers are having terrible trouble because they used to have a dry season and a wet season, and now it's all over the place and they don't know when to plant their crops. Get used to it, guys. And, you know, particularly the people who are working outside are really suffering already. These are really serious challenges. In the cold climates, oh, surprise, surprise, there's also a lot of thermally really bad buildings. Some of them are hundreds of years old and they are not very good. Again, inefficient burning of polluting fuels. When I was in Santiago, I was chatting to the person at the hotel and I said, oh, it's just acrid. It's like, the pollution's really bad. And she said, oh yeah, but we love our coal-fired barbecues to cook our steak. So it'd be interesting to see what the cancer rates are like over there. But anyway, in Siberia and other places, they have these incredibly inefficient district heating systems which are also coal-driven, so they're very polluting. And I'll show you in the next slide some of the poor controls that they've got. So I basically cooked in Siberia in winter, okay? I couldn't work out the controls for a couple of days, and even when I turned it off, it still didn't cool down. So anyway, and I think, so the big message from Siberia was that they're all overheating even in winter. And I'll go to the next slide and that'll show you why. So, so the top slide is the view from the lookout in Santiago over the coal smoke. The middle one shows the hydronic heating system for the district heated room. And you'll see it's got a very sophisticated lever. And I don't know about you, but I never know which way to turn the lever, you know. So anyway, we got the trouble is when I turned it off, you can see there are some pipes coming towards the heating unit. And there's such a long length of them in the room, and that still all stays with hot water circulating through it. So that was actually producing more heat than the room needed in winter in Siberia, without the heating panel even running. So there you go. And then the bottom picture, which you can't really see very well, but that is a hotel with lots of air conditioners on the outside. And basically, just about every building in Krasnoyarsk in southern Siberia is festooned with air conditioners because they've got these highly insulated buildings with double glazing and no shading, and the sun is still fairly low in the sky, so it sort of comes in and cooks them. So they all need air conditioners. So there's interesting things going on here. Now, so what are the lessons? Well, I didn't find anyone in Asia or Europe who were handling summer performance very well. There's an enormous task in upgrading existing buildings, and I must admit I was a bit daunted by that. just to see the scale of it. And the spectrum goes from, you know, tin sheds with air conditioners in some developing countries through to really high mass, poorly insulated, unshaded buildings in Europe. So it's not like any one of them has sort of a good solution with most of their buildings. And of course there were big variations in access to renewable energy and the types of renewable energy, so you've got to think regional solutions. I was a bit surprised that there wasn't as much emphasis as there is in Australia, really, in most of these places, about appliance efficiency. I mean, in some of the developing countries, they did have lots of appliance labels. In fact, in some places, the appliances had about 3 labels on them, obviously for different countries or something. But there's a lot. I was a bit shocked that everyone has a long way to go to really take control of energy, the demand side. And in Europe in particular, where I think people actually do obey laws, there's a sort of an over-reliance on mandated standards, and in fact, increasingly the policymakers trying to implement mandatory measures are finding that the econocrats are taking control over there, as they have here, and blocking a lot of action, and they don't really have other strategies that they can apply. In Japan, it was really interesting to see the significance of the Fukushima disaster, because we were looking at green buildings and new community developments which were being designed to be able to run without the electricity grid for maybe several days. And so it's not like you're arguing about cost effectiveness and all of those kinds of things. It's like, no, we actually want to keep functioning when there's been something really bad happen. And so it was interesting to see how that was playing out. Also, there is still a focus on incremental improvement, not a shift to zero emissions. And so, you know, the Russians are quite keen to keep using gas, and a lot of others are shifting to high efficiency gas boilers and things like that. And it's like, guys, that would have been a good idea 15 years ago, but we've got to move a bit faster. I didn't see enough thinking about system performance, or enough on maintenance, or enough thinking about life cycle issues, and about the significance of people's behaviour. Also, well, this holds in Australia as much as everywhere else. There's not a lot of understanding of just how much energy people really do need to deliver the fundamental services that they want. I don't know what we do about that. And then, you know, as I mentioned, the life cycle issue is becoming really important, because as we change technologies, the balance between different elements of the life cycle is shifting. And so that's where, this is a bit of a plug for some work I've been doing with a group called the Australian Alliance for Energy Productivity, where we've been trying to help business people break out of the traditional sectoral silo type thinking to realising that they are actually one element in a system that is going from, if you like, raw materials to a useful service like shelter or nutrition. And so this was the value chain, we call it, because you've got to talk about value and business benefit and things when you talk to business, we've discovered. But one of the interesting things for me, if you look at the third last point there for the operating, commissioning, maintenance, operation, what's interesting is when we break down the data for Australia, what we find is that the space conditioning is actually not that much bigger than some of the other elements in the supply chain, in the system. And so I think this is reflecting that, you know, we are improving our buildings a bit, but also we do have a fairly mild climate by world standards. And the reality is we are going to need to focus a lot more on the energy embodied in the materials and the technologies and the buildings that we've got, and also particularly in recovering the resources that are freed up by the demolition or removal and replacement of appliances or whatever. We are throwing away valuable resources, and we can't keep doing that. Okay. To me, there is some good news in this embodied energy space. Engineered timber products, tensile structures can use a lot less material than ones where you prop everything up. The car industry is pioneering lightweight, high-strength steels that are able to be applied in a lot of other places, changes in cement. And I must say, I'll give a bit of a plug to Beyond Zero Emissions here, because their Rethinking Cement report is really good. And they're doing some really interesting stuff in electrifying industry now, in particular looking at electrifying the energy-intensive high-temperature processes and things, which really not enough people have focused on so far. So there's good news there. Okay, I haven't gotten on to buildings yet, but I'm getting there. This is. I think this might be the last slide before I start talking about homes. I just must say I'm getting very concerned, even more concerned than I used to be, about climate change and how it's impacting on everything. And in particular, if you're building a house, you need to keep in mind that even in Australia, the average life of a house is like 75 years. And that's a long time, and the climate's going to be really different well before that house is demolished, hopefully. And just with relatively small changes in the temperature, the increase in frequency of extreme events is much bigger. And so we're just facing longer hot spells that are hotter and nights that are more humid. And, you know, this is becoming a real issue. And it's all very well to have people say, oh, you don't need an air conditioner. Well, maybe you don't, but then again, in a few years you might. And also we need to recognise that, you know, the elderly, the sick, the young, there's a whole lot of people out there, or there's also the people who are frightened of someone breaking into their house, or people who live near a noisy place, who won't be ventilating their house too much. So we need to really recognise these sorts of challenges that are coming through. The bushfire risk, I think, is a lot more worrying than a lot of people think, because it's not just the bushfire risk in one place will get greater. The reality is the bushfire risk is spreading to areas that didn't used to have much of a bushfire risk. And it's shifting. And so if you're building something that's going to last 70 years, you probably need to think a bit about, do I need to go for higher fire performance, or should I even build here? These are questions to confront. Again, there's increasing risk of flooding and inundation and overloading of downpipes and drains and things. And this is a few factors. One is the higher peak rainfall. And it has been pointed out by a few people that for each extra degree of warming that you get, the atmosphere can hold 7% more water. And this was brought home to me as I had some time between trains in Switzerland, in Lausanne. I don't know if I pronounced that right, but anyway, that's it. Where when I went to kind of go for a bit of a wander, none of the lifts or escalators at the station were working. And it's like, oh, this is a bit unimpressive. This is Europe, this is developed country, what's going on? And I didn't find out until I was chatting to someone on the train, the next train, where they explained to me that a few days before they'd had 40 millimetres of rain in 10 minutes. Keep in mind, you know, monthly rainfall in Melbourne's about 50, 60. And so apparently what had happened is all the lifts and escalators and everything were broken because of all the flooding, and they'd run out of spare parts. So, you know, there were these poor people with big luggage and, you know, walking sticks and things struggling upstairs and things like that because the whole system had failed. Yes, so there's lots of issues there. And also, once we push systems to their limits, for instance, like, remember Melbourne's trains, a lot of the air conditioning stopped working in the hot weather a few years ago? You know, we discover the limits of systems that we didn't realise we had. So there's increasing risks of failures, which again raise the issue of the resilience of how my home might work. Am I going to be dependent on the electricity continuing to run for my air conditioner? Also, there's the individual financial impacts on owners of land and assets and things like that, which again, if you've bought a block of land for your retirement home near the beach along southern Victoria, you could have an interesting time. So there's going to be a lot of financial pain, and I think also the psychological impacts of change are going to be very difficult. In the 2009 fires, my elderly mother was living in the Dandenongs, and I and my sister were sort of shuttling her backwards and forwards to my place in Brighton on all the hot days, and the logistics were pretty interesting. And then I thought, well, gee, if you had young kids or you didn't have someone in the city who you could stay with, there's a whole lot of issues there, and there's the question of the uncertainty. And uncertainty eats away at people in ways that can be debilitating over time. So, you know, there's all those sorts of things. So, yeah, that's cheered you all up, hasn't it? Right, okay, now we get into some nerdy building stuff. Except, well, you can see where this is nerdy. I thought I should talk about, well, what do we use energy for in our homes? And the answer is, well, it depends what indicator that you use as to what you think might be important. So the first bar on this side is the breakdown of electricity use. And again, this is overall for Victoria. So you could sort of say, well, this is for this mythical 2.5 person household that's got a bit of gas and a bit of electricity, and so it doesn't represent any of us, but it's the overall result. But what you see when you're looking at electricity, what's interesting is that in fact appliances made up by that pie chart are about half of the electricity we're using, of which refrigeration and the combination of TVs and entertainment equipment and IT equipment are really big chunks. At the same time, if you look at one of the small bits like pools and the pumps for them, that doesn't look like much, but what you've got to keep in mind is that less than 10% of Victorian households have a pool. So if you've got a pool pump's really big. Likewise, apartment common areas is only 4%, but how many of us live in high-rise apartments? There's a lot of energy waste in those common areas. So again, it's interesting to unravel all of this, at least to people like me. The second bar is gas, and you can see there that gas heating is the biggest user of gas in Victoria, followed by hot water and a bit of gas cooking. The final energy, the third one, is just the combination of the gas and the electricity. And because gas is not all that efficiently used at the end point of end use, the gas story tends to dominate. So the heating still looks really big, but hot water at the top and electric appliances are still significant. The fourth one is what's contributing to the summer peak for electricity demand, keeping in mind that household electricity consumption is something like half of total peak electricity demand in summer in Victoria. Right? So it's not industry, it's us. And what we see there is that pretty obviously not too many of us are running our heating systems on a hot summer day, so that's cooling, which goes from being a fairly small part of the year's electricity consumption to being a very large chunk of what's going on a hot day. But the appliances are still going fairly well, keeping in mind that the heat from all those appliances is actually creating a cooling load. So you get these funny interactions. Primary energy is the raw energy. So that's looking at the coal and the gas in the electricity. And so the appliances start to come up again as a bigger component of the primary energy bar, but the space conditioning is still pretty big because, of course, both the gas heating and the coal and gas for the power is coming through. The second last one away from me introduces a new bit, and it's probably not a good idea to paint it green, was it? That's the fixed supply charges. And so about a quarter of the expenditure by households on energy is actually fixed supply charges. And if you're a small consumer like me, it's like 2/3 of my bills. And I think they're doing their best to increase fixed supply charges for lots of reasons. So small households, I declare this is inequitable. It's a regressive thing to have high fixed supply charges because it affects me because I'm a small household. Anyway, the final one over the far side is the greenhouse gas emissions from the energy use. And again, you start seeing the appliances cranking up again, along with the space conditioning. So that gives some sense of what's going on. But I think when you look at all those different indicators, you can see how different your perception of life might be depending on which of these indicators you look at. And that's where, going back to that value chain, energy productivity is measured as, well, if you like, economic activity per unit of primary energy. And so what we found is that the electric parts of the value chain start to get a lot more significance than they usually do in most policymakers' brains. And it's interesting that primary energy is actually probably more closely related to costs and to greenhouse gas emissions than final energy, as in the metered energy that we see. So there's value in looking at different things like that. Given that appliances and things are a big issue, this slide is really about a hypothetical 2 to 3 person all-electric household, and the blue bars are how much electricity they would be using for, a typical household. And then the orange bars show how much they would be using if they were using best practice technologies, and I declare there's a bit of behavioural stuff in there as well. But there's a big message here, which is if we want to drive rapid change, we have to identify and replace a lot of faulty, inefficient, old equipment. And that's where there is enormous opportunity that is not being captured by, mandatory standards and stuff like that.
That's a 90% saving.
Yeah, easy. Keeping in mind, well, if you've got an old fridge that's using, 1,000, 1,200 kilowatt hours a year, the new 460 litre, one particular brand, not that expensive, is using 260. So there's 75, 80%. And certainly you've got to keep in mind the 90% saving is from the combination of the building and the equipment. And I'm talking about shifting from resistive electricity to a heat pump. So, there's always a story behind the numbers. But the key thing is there's a lot of opportunity, and the grey bars are just saying, well, what if we just push things a bit harder for a little while? Then, yes, there's more saving potential to come. And a good example there is LED lamps, which, the LED lights that you can buy today are nearly twice as efficient as the LED lights we were putting in a few years ago. We just haven't noticed that they're really getting a lot better. I won't go through these. These are just some of the priorities that policymakers might think about. In particular, my biggest frustration is that I don't understand why every appliance that we buy doesn't now have built-in smart diagnostics to tell me if something's going wrong. We keep running our air conditioner or our fridge until all the gas is gone, instead of being told, oh, I think you've got a gas leak, fix me now. And that would save a lot of energy and a lot of wasted refrigerant. Likewise, we know that particularly in the commercial sector, a lot of commercial fridges, all the heat exchangers are all clogged up with dust. That's adding 20, 30+% to their running cost. These are things, it's not rocket science to just put in a smart diagnostic system now. I won't go on. Right, okay, here's the test. This is where I get nervous. This is the thought experiment, the zero energy bill home and car. I should point out Tony Isaacs, who many of you may know, who's a buildings guru, is a good friend of mine, and he and I were writing about this, and he got all excited about it before I did, so I've stolen his idea. But basically it's kind of interesting that it is feasible to save $2,500 a year if you combine the savings on an electric car and for your house, and you can use it on holidays too. So, it's got multi-purpose. Yeah, exactly. Yep, exactly. So I assumed that. And it's interesting because, in fact, I worked out that this backup generator would cost about 60 cents a kilowatt hour running on petrol. If you're avoiding the fixed supply charge, you're way ahead if you're just using it occasionally. So there's kind of interesting things going on here. Anyway, yes, and also people would have all the e-bikes. So the structure of the system, you can see I wanted this smart interface between me and the rest of the world. And I wanted this smart interface to treat the grid, backup generators, TVs, all these things the same. And I wanted it to focus on looking after me as the top priority because I am the one who's spending the money. So I deserve to be looked after. And I guess one of the things I find a bit interesting is that so many people in the energy sector talk about using me and my technology to help optimise the grid. No, if they're prepared to offer me a good enough deal, I might be generous enough to help them out. But, I'm the one who's paying. So I think there's some interesting issues here. The other thing that I've got in this at the end is the concept of high peak load appliances actually having their own storage to minimise the wiring costs and everything within the house, because that's something no one ever talks about, except people like me who want to put an induction cooktop in an all-gas house that's fairly old and gets a quote that's more than the induction cooktop. So there's some things to think about with that. Also, I'm very big on the concept of integrated systems, and this just shows you the daily output of a PV system in Melbourne, a 5 kilowatt PV system in Melbourne in the hot months and in June. And we need to recognise that if we've got a PV system, it is not the silver bullet by itself. It's a really good thing to do. I'm not saying it's bad or anything, but you need to remember you'll have a lot less power in winter, and you could have a few days in a row where you don't have a lot, which is why you have to have either a backup generator or a portable import-export device called a plug-in hybrid or an electric vehicle, which you can borrow some electricity from someone who's got too much and top up your battery with that. And in fact, this is one of the things that, a lot of people who work for grid companies keep saying, oh, you'll have to be connected to feed all of your excess in summer and then you'll need us in winter. Well, I don't know, if I had an electric vehicle, I could probably sell some of the power, for more than they were going to pay me. So there's interesting kinds of options for us, and it is a question of none of us really knows how this will all play out, but lots of the people who are doing the thinking and making the decisions are actually only seeing incremental change, and they're not stepping right back and saying, well, if I didn't have the grid, but I did have an electric car, how would I try to do things? So interesting to me. So the key message for me is look, you want to have a mixture of things packaged together so that you can get the best outcome for yourself. So if you go down here, the top thing, if I've got an energy efficient building with energy efficient equipment, that reduces my annual consumption, and typically it will reduce my peak demand a lot as well. If I've got smarts to manage my demand, then I can shift my usage away from the peaks or to the times when it's cheapest or whatever. If I've got some energy storage, and there's increasing different options for us, then that provides me with the stored energy when I need it, and it breaks that linkage between the supply system and me. But you need to keep in mind that energy storage systems use energy. They lose some energy in the round trip. So again, something to keep in mind. Then obviously energy production on site, most of us would look at rooftop solar for that, but you can have local and regional solutions. And then last of all, you can do energy trading, and you could do it through the grid or via your import-export vehicle. And energy trading allows you to import or export when you need it or want it. So all of those things together start to deliver a really interesting and I think nice story. Exactly. But out of all of this, one of the other things that emerges is a need for stronger consumer protection mechanisms, because you could be dealing with, 3 or 4 different mobs, one of whom goes broke or whatever happens. And that's where the proposal I've been thinking about relies on a model that's a bit like the no-fault third-party insurance scheme we have for cars. Because let's face it, if something goes really wrong with my inverter or my PVs or whatever, I would like someone to fix it really quickly, or with approval, throw a power lead over the fence to my next door neighbour, or however, I don't know. I just want to keep getting my services, right? That's what I want. I don't want to get caught up in an argument between 3 different companies blaming each other. And so we need someone big to do all of that on our behalf, and that's, if you like, that's what the third-party no-fault insurance mechanism does. It's got someone who makes sure you're looked after and then sorts out all the legal details and the blame and the responsibility and that, and is big enough to not be beaten into submission or worn out by trying, by running out of energy to fight. Right? So we've got to do something really different in consumer protection. Okay, what's this one saying? Okay, now what I'm going to do now is just talk about home comfort, cooking and hot water and lighting just very quickly. Actually, I'm not doing too badly. Yeah, we were feeling a bit awkward about me going on for an hour and a quarter, so that's okay. So what I've got is some criteria that I'm going to apply when I look at these different activities. So 1, peak demand. Peak demand matters. Why? First of all, because I think the energy suppliers are going to increase peak charges, and they may well start setting them the way they do for businesses, where in Victoria they look at your highest demand in the last year and say, well, you've got to pay a monthly charge based on that. And if you listen carefully to some of the energy companies, they're talking about the mobile phone model. If you want high speed and lots of gigabytes, you pay more, even if you don't use them. Right? So this is a very interesting path, and they're arguing this because they're saying, well, there's going to be so much renewable energy with a marginal cost of near zero. How are we going to make money? Charge you for capacity. So we need to keep that in mind. So if we've got really low peak demand and we have the smarts to make sure we never exceed it, we're in a better position to do a deal. Obviously, if you're grid connected, power failures are most likely to happen when you've got high demand. And also, if you've got lower peak demand, you can have a smaller PV system, inverter, smaller storage, so you can save lots of money when you look at the overall system. And I'm a bit obsessed about this, and this is more for existing homes, isn't it? This idea of reducing the electrician's fees for upgrading your wiring. Right, consumption matters. And consumption matters because on the whole, even with what they're trying to do, higher consumption probably means higher bills, and also it usually means higher peaks. So they're kind of linked. Also, you need to keep in mind is that if you've got high winter consumption, that's when your PV output's lowest and you'll have the biggest problem. So I would put a weighting to try to limit my winter peak demand or my winter consumption. Building design and appliance and equipment selection matters because, as I said, a house is going to last 75 years. It's locking you in because it's really hard. I can vouch for it. I've written the article about trying to get insulation in my brick veneer walls. There's a lock-in factor, and even with an appliance, if it's a fridge, it might last 15 or 20 years. So you need to think about the long term. And at the same time, on a positive note, building performance, if it's good, can lock in your comfort, better health, and also capital cost of heating and cooling equipment and the resilience of your house if your air conditioner fails on a hot day. If you've got a good building, it'll keep cooler for longer. So there's a whole bunch of things like that. There's also this extent of intervention. I think, I don't know about everyone else in this room, but what I like is a house that just sits there about the right temperature. without me having to remember to switch things on and off and the noise of the fan and all that stuff. And I think there's something that's good about not having to actively drive your house all the time. Oh dear, behaviour. Ooh, yes. Behaviour is a really big issue, as some people in this room well and truly know. Okay, so you thinking about those 4 criteria, what are we going to do in terms of comfort and health? Okay, so I haven't used the words heating and cooling. All right, I've used comfort and health because that's what I think we're on about. So, first of all, the graph at the bottom there just shows basically if you had a 7 or 8 star house, what your peak demand would be relative to an uninsulated house on a hot summer afternoon. Actually, this is quite old. 38 degrees I thought was hot when I did this. Well, 45 now I guess is what we're looking at. So, anyway, but the point still holds that a good building has a lot lower peak demand, which can help in lots of ways. The other thing, the very small table up the top there, I'm sorry that's all fine print, but that looks at an insulated wall, an uninsulated wall, a super duper triple glazed, low E argon filled window and a single glazed window. And so if you're looking, for instance, at the conducted heat, you can see the single glazed window is 88 watts and the R3 wall's 5 watts. If you look at the radiant heat, well, there is some radiant heat from the walls, but it's really hard to calculate and it's not very big, so I've left it out. But the interesting point there is that the radiant heat flowing even through the triple glazed, low argon, argon filled, low E thing is still 100 watts with 500 watts of heat load. And this is something that a lot of people don't get, is that even really fantastic windows are not very good in terms of heat flow if they are exposed to sunshine. And shading is really, really, really important. That's kind of the main message from that complicated table. Yeah, so I reckon, we need a high-performance building fabric. I think we are moving towards energy recovery from ventilation, and I noticed Trivess is doing some research in that space. It's not for all the time. A lot of the time we can let our house go free and have windows open a bit and things like that, but once you get in really hot weather and really cold weather, the energy involved in that air coming in and out is actually a big part of the total once you've got a good building. So I think we're going there. And again, to me it's not either or about natural ventilation and heat recovery ventilation and sealed houses. I like to be able to open up a house when it's convenient and it feels nice and the weather's right. But the reality we're facing is Mother Nature is getting less friendly and the extremes are becoming more difficult. That's how it is. I've talked about exposure of glazing to sun. Light-coloured adjustable shading's good. Adjustable shading's great because, you can get really hot weather in March now and that's when the sun's getting towards the equinox. So we need to think a bit about adjustables. Also, lots of people say you should face your house exactly north. And I'm not so sure about that myself. I quite like a bit of winter morning sun coming in from the northeast to take the temperature of my house up quickly to a level that's nice. And once it's up there, it'll stay there the rest of the day. Keeping in mind that northeast window could be a real problem in summer if you don't have adjustable shading and systems to control that problem. So, nothing's magic. Consumption, again, I've talked about that up there. The highest heating load occurs when your PV output's lowest, which is an issue. So again, you want a good building that works well in winter. Sorry? I don't know the answer to that. I'm not a supply side kind of guy, so others might answer it. You know, you can do a bit of everything, I guess. Anyway, you can go into PV Watts and model it all, or pay someone to do it, not me. Use the simulator. There you go. Plug for ATA. And the highest cooling load's the major driver of system peak load, so you need to think about that as well. Building design. Oh, that looks a bit familiar. We'll come back to that. Oh, locking in consumption. Oops. Oh, hang on. Oh. Anyway, it doesn't matter. So, yeah, behaviour. One of the classic issues that some RMIT people found was that lots of people like to keep windows permanently open. Just a bit. And again, if you think about it, if you've got two windows or two openings on opposite sides of the house and the wind blows, one of them is a great suction system to remove air from your house. So there's issues there. Okay, this is just a few thoughts which I might skip over because I should try and finish soon. But just, you know, there's also getting the microclimate around your windows and your house right helps. There are interesting daylighting options emerging. You can get translucent aerogel insulation, which is super performance insulation, but you can't buy it in Australia. Just Europe and Canada, I think. You don't have to have opening windows. You can have openable insulated panels. You don't want problems of a window, but you want to be able to ventilate. In the exhaust fans and range hoods are significant. I'll cover that in a minute. Thermally efficient retreat rooms are quite an interesting concept, and I think Renew had an article about such things a while ago, and you know, particularly for people who are vulnerable, helping them get a really good room that will work and even enough energy supply to keep it comfortable could be a really good thing. Radiant heating and electric throw rugs, there you go, there's a pretty interesting kind of throwaway line. Ceiling fans, again, you know, some ceiling fans are much more efficient than others. Choice has lots of info on that. And again, reverse cycle air conditioning, if you do it right, can be great. What the bit over the other side is about is one of the problems with ducted heating and cooling systems is that for them to be efficient, the air has to get out of the outlets and back to the return air register. And often it is easier for outside air to get to the return air register than for the air to fight its way back. So the bar chart up the top just shows a test that was done in the US where they had all the internal doors open and no heating running. Then they had a bit over double the air leakage when they ran the ducted system. And then as they close more and more doors, they end up with 8 times the air leakage, because basically once you close the door, the duct in a room can't get the air back to the return air register, so it kind of leaks out where it can and a whole lot of outside air comes in. So I don't have a great solution if you don't want to have lots of split systems around, but ducted systems can be very unfortunate. Okay, now this is some work Tony Isaacs provided me with. Lots of people, well, you pretty much have to get a house energy rating done when you build your house. You should ask your energy rater to run the house in free running mode for the representative hot week and cold week. Because if they have broken your house up into the zones or the rooms as they should, that will really help you understand much better how the different parts of your house will work. So if you look at the top one over there, you can see that one of the living areas is pretty much tracking the outdoor temperature for the 6-star rated house. and its other living zone is still not all that fantastic. The 9-star house, consistent with what Trivess was showing us, actually tracks a fair bit lower right through the whole time. Again, on a cold winter's day, the 6-star house does still cool down a fair bit. The 9-star house just kind of sits around. So again, what you'll also find is that the rooms on the south will tend to run cooler all year round. The rooms on the west will cook on hot afternoons. You know, every different part of your house performs differently depending on its own microclimate. And it's really useful to think about what you're getting and what you really want from different rooms. Okay, cooking. I'm nearly finished. Induction cookers, if you're trying to heat up a heavy pot and a reasonable amount of food quickly, you can have quite high peak demand. But the actual amount of energy consumed is not very big. So doing that kilogram of steel and 1.5 kilograms of food and water only use 0.3 of a kilowatt hour of electricity. And so, and also even efficient electric ovens still use quite a bit of power, including quite a bit to warm up themselves because they're heavy metal. So there's interesting issues here about how to deal with that, which I'll cover a bit later. In terms of consumption, induction cookers are the most efficient. They've got a gas cooktop's got 4 times as much waste heat going into your room as an induction cooker. And you can see my beanie on top of my pot there. You could not do that with a gas cooker or with a traditional electric cooker because it would catch fire. Right? But I can tell you it hasn't so far. And I thought it was also cute. When I was in Beijing, I went to this traditional tea ceremony and they were heating the pot of the kettle on an induction cooktop. So there you go. The world changes. Yeah, so again, in terms of induction cooktops, what I want is something that I can plug in to the normal power point and has a bit of battery capacity and some smarts so that I can top up the main supply from a plug without an electrician having to come, and then still get the fast cooking, but not with the fast electrician. So all of that seems all pretty feasible. Also, what's interesting is that everyone gets excited about induction cooking, but it's not as efficient as a resistive electric heating element, actually, if the heating element is inside an insulated container, which, of course, I've never found something that does that. Maybe you have. And lightweight ovens are the way to go. And use exhaust air to preheat the incoming air. No, I haven't seen one that does that. Behaviour, cook in bulk. Put the lid on things. Boiling water is very energy intensive, right? Phase change. And yeah, you know, and don't try to cook things that are still frozen because the resistance, the thermal resistance of the outer bits of the food means it takes a long time to make it safe to eat. Hot water, this is very quick. Resistive hot water and solar boosters with resistive electric heating have high demand, and going down here, solar requires most of its boosting in winter when you haven't got lots of energy if you're trying to minimise your grid dependence. And the best heat pump water heaters are looking quite good. Yeah, I'll skip over the rest of that because it's fine print, really. And then lighting, again, LEDs are just truly remarkable, but you still don't want to cut holes in your building to put them in because that creates air leaks. So there's a bit of detail in there. And you should always switch things off if you don't need them anyway, I think, but there you go. Okay, last slide, just to highlight. Use the energy rating website to select appliances because the difference between the best on the market and the worst on the market in most product areas is large. And you don't have to buy the absolute most efficient one that's really expensive. There are lots of really good ones that are reasonably priced. But again, you know, this just highlights how badly governments have done mandatory standards in Australia, because really half of those products should not be on the market. But, you know, the world moves slowly. And this is just a few other little snippets about old plasma TVs. If you've got an old plasma TV, or if you've got a TV that has a fan, you have an inefficient TV. Heat pump clothes dryers are getting cheaper, which is good. Refrigerant leakage is a big issue we have to deal with, and there's ways we could do that. And there are lots of exciting emerging technologies which will be more and more efficient. And the frustration is we don't have a major research and development program to drive all of this. And often the reason is, oh, well, you know, overseas will do it. Well, you need to be actively engaged here, because otherwise we are the dumping ground. So we really have to do a lot better in this space. And with that, I'll stop, except it's not discussion and Q&A, it's Donna's turn. Right.
And interesting, Alan, talking about also the climate refuge, because I know Tim Adams, where are you, up there, you're working on a project at the moment in Geelong looking at, I know, do you want to quickly talk about it? And while you're doing that, I can get my slides up.
The Virtual Centre for Climate Change Innovation, which is the state government initiative, has issued drafts to a whole range of projects recently. One of them is the Climate Safe Rooms project that has been run by Geelong Sustainability Association, CSIRO, and Uniting, and the Council. So we look at putting increasing the energy efficiency of dwellings and concentrating on electricity, which is what Helen was talking about. Going into a house, finding the rooms that are most efficient to start with, doing electrical work in those rooms, putting a reverse cycle unit like a data USC, which has been published in performance of about 6, and then putting 1.5 kilowatts of electricity on the roof, which will generate more power than the additional use. What we're told by social service people, there's no point putting an air conditioner on a house if the resident thinks it would use power and cost more as well. So we have to do it there and show them that the previous system will actually not power the air conditioner, but will reduce their demand of electricity. That has started and will run through for 2 years, through to the middle of 2020. The CSIRO monitoring equipment that's going into the world, not only look at thermostat settings and comfort, but it will also look at behaviour, because it senses we know that the person moves from room to room, when the time that they're actually in their bed, all those sorts of things. So that really data set to see how well.
Cool. Excellent. Thanks, Tim. And in that time, I got my slides up and worked out how to get rid of that emergency button that comes up as well. So that's quite good. So I'm Donna Luckman. I'm the CEO of the Alternative Technology Association. And hands up if you're a member of the ATA here tonight. Whoop, majority. So keep your hands up. Now, I want you to put your hands down as I count down how many years that you've been a member. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I think I go down now, 16, 17, 18, 19, 20, 21. This could go on forever because.
Only to 1981.
Yeah. Because we've still got 4 people here who actually still got their hands up, being a member over 20 years. I know at least 2 of them are life members, so they're actually going to have to keep their hands up forever. So can we just give a clap to the people who have been members of 20 years? So I won't tell you then who the ATA is. So I might just tell you a little bit of some of the activities that we've been doing recently, and following on a little bit from what Alan's been talking about in working a bit more in housing and what we're calling climate resilient homes. So as you know, the ATA is a not-for-profit organisation that's been operating since 1980, and nowadays we reach about 250,000 people a year through all the different services and programs that we provide. And we're all about making sure that we inspire people, we enable people, and also we advocate for change for people as well. And you probably know a lot of the inspiring work that we do, especially with our events. Sustainable House Day this year is going to be on September the 16th. We've already got 140 houses registered to open. We're expecting over 200. So if anyone here would like to open up their house, I know there's a few people here who have in the past, please let us know, because it's still possible to do that. Last year we had 29,000 people come through and look at the different houses around the country. And once again, we're joining with the CRC for Low Carbon Living, who have been tracking the impact of Sustainable House Day over the last 3 years since we've taken ownership of it. And the results from the CRC is that within 3 weeks of the event, over 20% of people have already done something in their home, over 50% of people identified what they're going to do, and 90% of people had already talked to other people and did word of mouth for what they learnt on the day. So for us, we know that Sustainable House Day is a real strong vehicle to get really vital information across to people. We have our speed data sustainability expert events that we run with local councils. We're doing about 10 of them a year, and that's all across the country. We've already done 2 in Perth this year, a couple in Sydney and quite a few in Melbourne as well. We've also got the Melbourne Electric Vehicle Expo, and that's going to be on again in February next year at the go-kart course down in the Docklands down in Port Melbourne area. Last year we had over 5,000 people turn up to that EV Expo. We actually got totally swamped. If you're there, you might remember. We're also going to keep on inspiring change with our magazines Renew and Sanctuary. We've also got our online resources. I talked about the Sunulator before, but you might not also know that we've got a free solar and battery calculator on our website as well. So you can actually just put in 4 really simple bits of information, like your postcode, if you're high or low energy user, if you're at home during the day, and we can actually pip out a report to you on what different options for solar and battery storage would be, how much it would cost, and what will be your return on investment as well. We're also going to keep on enabling change through some of the different areas we do with our research. Our biggest research paper we released earlier, well actually just about a month or 2 ago, was our 100% electric homes. So this is a follow-up to research we did a couple of years ago, which is looking at if you go to an all-electric house, getting rid of your gas service charge, and also moving to a lot more efficient appliances, including heat pumps and also induction cooktops. What is the economic benefit of it? And it usually is across the country, especially if you're building a new house. It's much better for you now to actually go to an all-electric home, especially if you can incorporate PV with that to offset some of the work as well. We've also expanded our advisory service. As members, you might know that you can actually call up the office or email and get free expert advice for about 15-20 minutes. We've actually developed that now into a consult service, which actually uses a lot more in-depth information. So we can get your smart meter data, a lot more information from you on your bills. And we can develop about a 20-year energy management plan for you, looking at the different options. Once again, it's always asking you what are your motivations and what you want to do in your own home. Is it because you want to save money? Is it electrical savings? You want to go off the grid or energy independence? And all those different answers will help us guide us in what the information we give to you in your advisory service. And I like to use this one because this was actually when the checkout, when they just did their about a month or 2 ago, a series on solar, and they really plugged the ATA as the go-to advice service or on solar, and plugged our free calculator and our advice service as well. So I'd like to say now that's ATA seen on TV. We also continue to do a lot of advisory group work with community groups and companies across Australia, and we're very active in the Coalition for Community Energy, and through that we've helped quite a lot of community energy projects across the country. The picture you're seeing here down the bottom, this is the Carawan Aboriginal community over in WA. We worked with them about 2 years ago where they actually, so just outside Kalgoorlie, they're on the mains grid and they've got one actual meter to service the whole community, which is about 30 buildings, and they're on an extremely high tariff. So they came to us wanting to reduce their energy bills, and it's actually thanks to Rob Sim down here in the front, who have been working with Carawan for a few years, that hooked us up with this project. And we worked with them and actually did the feasibility work on how they could put in a solar system and over what savings they can get to that community, and also what they can negotiate with actually their retail and distributor as well to get on a better rate. When we came up with the feasibility study, they actually didn't have the capital cost to actually roll out that solar system at that time. So we partnered with two impact investors who actually came up with a model in which they will pay for the capital costs of that system and would have a loan that would last for about 6 years, in which they will get a return, but that at the end of that time, the community would own that solar system outright. And also from day dot, that community was going to get energy savings as well from that system. So as well as paying back that loan, they were going to get the energy savings as well. So that's a really lovely project that we work on, and it just gives you an example of some of the feasibility work we do with local communities. And that model, working with impact investors, is one we like to replicate as well. So if you do know of any other communities who might want to work on this type of project, please let us know. And of course, we'll keep on doing our advocating for change as well. So a lot of our advocacy work in the past has really been in small-scale renewables and rooftop solar. And we started doing our first bit of advocacy work at the ATA about 15 years ago, when it was probably people in this room who were putting on their solar systems and actually ringing up their retailer going, hey, I've got my solar system in, can you connect me up to the grid, and what rate are you going to get me? And what was the answer you got from on the end of the phone was, what do I do with you? So what we need to do so we did a lot of advocacy work at that time to look at how we can get standardised contracts for people who actually connected up to the grid. I also advocate for a fair price for people actually putting their solar back into the grid as well. So we like to think that the 1.8 million Australians who now have solar on their rooftops have been helped by all the advocacy work that we did so many years ago to actually standardise that contracts and make that a smoother experience for consumers as well. Community, we're part of a growing community as well. This is part of it. We've got 14 branches across Australia who have regular events like this one tonight. And our community keeps on growing as well with the different events that we've been holding, such as Sustainable House Day and our Speed Date Sustainability Expert events. And partnerships. We're all about partnerships, because not one organisation can tackle the challenges that we have at the moment with climate change. It's about working with different organisations, and there's a lot here that are represented here tonight. And I really love this photo, because this is actually a photo from the Community Energy Congress in February last year. There's many people that went to that Congress. Yeah. It was a fantastic event where you had over 500 people across Australia converge in Melbourne just to talk about community energy. And I like to think that the community energy, it's all about the community. Like the generation that's going to come out, it's not going to be as big as some of the biggest solar projects or the bigger wind projects, but it's actually getting all this community together, helping each other and giving that social licence to talk about renewable energy and energy efficiency as well. So I really love that photo from that actual event.
Is that a real clever word, that generate?
Sorry?
Ooh. Is it a spelling mistake or a clever word? It means something else.
It means you get a prize. But what I wanted to talk a bit more tonight is following on from Alan's presentation on housing. And we went through, as an organisation with the board and staff, a strategic planning process at the end of last year, identifying what we should really be focusing on our efforts for not even for the next 3 years, but what do we want look like in 12 years' time, the external environment, and what's the role that the ATA needs to play. And the one area that came up for us that we need to do a lot more work was on housing. We need to be advocating more for better quality housing in Australia, and we need to make sure that we can actually get more energy efficient housing, and that to be the norm and not to be the exception that we actually showcase on Sustainable House Day. So for us, the move to better design zero carbon housing and just has overwhelming positive benefits for households, and Ellen's already touched on this already. It's about improving the health, it's about improving the comfort, it's about reducing the running costs, it's reducing emissions, but also making our homes a lot more resilient to the climate that is changing at the moment. And I think I've been really concerned, as other people probably has been, getting the news coming from the Northern Hemisphere in the last month or two, with the extreme heat, the floods and what's been happening. But I think I was even more concerned when I saw on the ABC about a week ago that we had bushfires in Maffra and East Gippsland last week. And it's this time of year, and for me that's quite shocking. So we need to make sure that we need to advocate for this better housing. A little bit for us is that also, there's a couple of things that we need to start acting on this now, and Ellen had a bit of a part of this as well, where we were in this room about 3 months ago, and Trivess organised this event where it was Ellen and Tony talking about there's actually a whole lot of work happening at the moment that we need to get engaged on into sustainable housing. And some of that work is coming from Climate Works, who have been working with Australian Sustainable Built Environment Council, who have been putting out a series of reports on what we should be doing to increase the energy efficiency of the residential sector in Australia. And I think this fact really brought it home to us that 58% of Australian buildings in 2050 are going to get built post-2019. So we are going through a huge transformation in our housing stock at the moment. And up to now, we're always thinking that the new builds are such a small part of the market, but that's increasing and changing. And for us, if we want to be looking at the houses in 2050, we need to start acting now to make sure we get those houses that are better quality. So there's quite a few things in train at the moment, and as I said, we were in this room about 3 months ago, and Ellen and Tony's really fleshed out to us what is happening in at the moment. So there has been no increase in the minimum standard of residential buildings since 2010. So we just finished off the 2019 process for changes to the National Construction Code. So the National Construction Code outlines that, what the minimum standard would be, which at the moment is 6 stars, which then all the different jurisdictions have to roll out. But in a way, the process for, even though 2019 hasn't really officially finished, the process for 2022 is actually starting this year, because the COAG Energy Ministers instructed the Federal Department of Environment and Energy to go off to about what they're calling the trajectory for low energy homes. And what this is basically looking at what should be included in the National Construction Code and a whole other measures in the National Energy Productivity Plan that the COAG Energy Ministers should be looking at. And if I get this wrong, Ellen can jump in at the moment. So basically, the COAG Energy Ministers have to actually direct to what will finally be the Building Ministers Forum, what they should actually even think about including into the changes to the National Construction Plan for 2022. So even though that process hasn't started, we need to be influencing those COAG Energy Ministers now to make sure that even if we want increase to residential minimum standards, that it's even on the agenda. So for us, it was a real kick up the bum to know we need to start acting on this issue because it's quite important, and we need to be engaging to the trajectory below energy homes, and we have been doing that. So we've been very fortunate to get some little bits of philanthropic funding to actually be engaging not only in the 2019 but also the low energy homes recommendations as well. John?
Trajectory for a zero energy home.
Yeah.
Or energy quality.
You can make that submission to the process. And I think also for us up to now, that the only voices that you're hearing in this debate is always industry. We're never hearing about the consumers, and the consumers are the ones who live in these houses and actually pay for the building of them or paying the rent for them as well. But they seem to be the voice that's missing in this debate. So we're looking at doing what we're calling our Climate Resilient Homes program over the next 3 years. And this is leveraging over the 35 years of knowledge that we have in the building sector, also the networks that we have, and also the expertise that we want to work with a lot of people in this room, so we can actually make a real difference and improve the minimum standards at homes, and also what we should be doing about existing houses as well. So it's 3 areas that we're going to work in. One is advocacy. So this is engaging in the formal processes of what's already happening at the moment for the trajectory for low energy homes that John can send his submission in to make sure it gets changed. So we're engaging in that process, but also we're engaging in the process for the National Construction 2022 when that officially starts. But also we need to engage in all the lobbying that needs to happen outside those formal processes as well. We need to make sure that the ministers making the decisions know that there's a whole group of consumers out there who actually want to increase the minimum standards of houses, and actually they should be acting on the rights of the consumers and not just some of the small industry voices as well. And since we've been doing this work over, it's only been the last 2-3 months, we've been talking to a lot of our colleagues in the environment and the social sectors as well as the building sectors. We've been able to get quite a lot of momentum already, to the point that in about 2 months' time, Energy Consumers Australia is pulling together and having a housing summit, and that's going to be on September the 5th up in Sydney. And that's going to bring together not only groups like the ATA, but also the Australian Council of Social Services, a whole lot of housing and consumer groups. And from that, we're all going to get together and put out a group communique calling on the ministers to actually come up with some national plans on increasing the energy efficiency of all Australian homes. And that's going to be a first that's ever going to happen as well. So within 2 or 3 months, we've been able to get quite a lot of momentum already, but we need to actually do that over a longer period of time. So that's the advocacy piece we're doing. The other piece we're looking at is some research, and this is following on a little bit to Alan, your little experiment with doing your little home research on what could be the payback time or investment on a home. Because we know when we start talking about increasing standards that we're always going to get the noise that, oh, that's going to increase the cost of homes and no one was going to pay for them. So we're trying to do the research to show that, well, one, it might not cost that much more, or if it did cost a bit more, then actually the payback time is going to be so much, you probably, with your reduced bills, that you can actually probably reduce about 3 years or 4 years off your mortgage. And we've done some of this work previously at the Cape Patterson development, where they've got an 8.2 star house. It's on a heat pump for hot water. It's got reverse cycle heating and cooling. It's an all-electric house. And we did a bit of an analysis of theirs, and they've been able to reduce their bills by $2,000 a year, and also they'll reduce their mortgage by 3 years as well. So what we're trying to do is get that evidence base, because we might do this crazy thing called evidence-based policy. I know it doesn't happen very often, but we'll try, to actually show that if we have more efficient houses, it actually reduces the ongoing cost, and also can actually probably reduce the cost of the mortgage as well. So similar to the experiment you've been doing as well. And it is a very hard piece of work to do, and we've been taught to do CSIRO and quite a lot of people because, as probably Tim would say, how long is a piece of string when you're talking about increasing the star rating of a house from like 7 to 8 stars? What difference does that make? Because if you actually make the changes in the design phase, it's going to actually cost you so much less and really minimal cost than if you're going to try and do all the add-ons, if we talked about like with double glazing or other things as well further down the track. So for us, it's trying to get a bit more of an idea of the research and the cost of building at these different types of houses. So if there's any builders here, we would love to have that conversation with you as well to get some of that data. The third area that we're going to do working is more on consumer education. We have so many people who even use our advice service, and the first thing, and they're wanting to know how much it's going to put into batteries and solar. And the first question we always ask is, so what's the star rating of your new home going to be? And none of them even have an idea that the houses do have a star rating, or two, that they even haven't got to that stage yet to ask to get that assessment done. So for us, we want to do a lot more consumer education around making sure that people ask their builders what their actual star ratings are, know what questions they should be asking along the journey of their builder to make sure that it's actually complying to what was actually designed, to what actually ends up getting built as well. And we've been talking to lots of people on, because the big issue here is along compliance, and it's such a complex beast when we start talking about compliance with what actually gets built. So can we arm the consumers with checklists and other facts that they can actually then go back to their builders and go back to their designers to make sure that every step of the way that their house is getting built to what they actually thought they were going to get. So for us, this is what is a major piece of work we're going to be working on over the next couple of years. We're talking to a few philanthropic trusts to actually fund this work as well. And we see this as really bringing together a lot of the years of knowledge that we have at the ATA. Because, as Ellen's already pointed out, it's the multiple benefits of energy efficient housing. It's about reducing our Australia's carbon reduction targets. It's making healthy and safety homes for occupants. It's reducing the cost of living. It's reducing the peak demand. And also there's some broader economic benefit as well, with not all this infrastructure costs going in to actually deal with that peak demand. So once again, we're going to use ATA's knowledge and networks to work on this program. And for us, it's, the time is right to actually act now and actually bring all this knowledge together. So I'm more than happy to have a conversation with people a bit more about this program and also what skills and experiences you can bring to it as well. So that's that piece, but I think everyone did a bit of a build-up that the Donna's secret surprise coming. You're going, well, Donna, that's really interesting. You're doing some advocacy work on climate resilient homes, but there's actually a bit more of an announcement that I'm going to make tonight. And who here used to watch Get Smart? All right, we're about to go into what we're calling the cone of silence. And I always get told I shouldn't use that because I think the cone of silence never used to work. But let's pretend the cone of silence. Yeah. So this is a bit of a secret, and we're going to make a public announcement about this in the next day or two. But the ATA, we've made huge advancements in the last few years from our humble beginnings that some of the people here in this room probably know about. Well, it was actually just a group of enthusiasts getting together in a Brunswick town hall to talk about what they can do to tackle fossil fuel pollution and what's a practical, positive story they could do. But today, the ATA inspires and engages with 250,000 people each year, and the national organisation keeps on growing, and there's more households and communities who actually want the knowledge that we have, and we need to spread that to more people. But for many years, we've had a lot of people question the use of the word alternative, because what was once alternative is now mainstream. We've got 1.8 million people with solar on their rooftops. And in some forums, alternative is considered less credible when we're being seen as a professional, independent, not-for-profit organisation. So, shall I do a drum roll? To overcome this barrier, we're changing our name to Renew. So the name change is not going to change what we do. It's just going to help us to reach a broader and more diverse audience of people. So we're still going to be producing Renew and Century magazine. We're still going to be running Sustainable House Day and Electric Vehicle Expo events, the Speed Data Sustainability Expert events. And we're still going to be advocating so people have more comfortable, healthier and resilient homes. But we're just going to be doing it in a way that we're going to try to reach a broader amount of people. We're going to be integrating a lot more of our different systems. People might not know, we've actually got 7 websites at the ATA. So if you went to our website trying to find information on solar, it's actually quite hard to find because you might go to the main website to use a calculator. Then there's that article in Renew, and I'll go over there and find that. And then actually the Melbourne branch is having something on solar, and that's over another website over here. We're actually going to integrate this all into one website and one sustainability portal as well. And over the years, our members keep on telling us that we need to reach a broad amount of people and get our knowledge out to more people. And we feel like we need to do this step change to say we're not alternative anymore. Every person in Australia should actually have the type of homes that a lot of us already live in. We need to make sure that it's actually the mainstream for all of us to live in these comfortable, resilient homes. So I thank you all because so many people here have been a long time on the journey with us. We also want to make sure that we broaden out and have more people in part of our community of change. So we'll be making this announcement to all members in about the next day or two, and I'm just really excited that I got to share it to you tonight as well. But it's a secret. Sorry? Did it? Oh. Don't know who pushed the send button then. So that's all for me, and now we can do Q&A. I think.
Well, you can after yourself. Yeah.
We should be right.
Hi, I just wanted to mention the future really has that we're just starting here at RMIT. It's funded by Trivess Australia, so from a very much advocacy perspective, trying to get the household voice out into the sector and better decisions around energy, renewable energy, and integrating into the grid. Some of the issues that Alan kindly already mentioned that we're grappling with in this project are peak demand, household participation in the grid, are they rewarded for that in the future, sharing energy, how we're going to accommodate energy into the grid for distributed energy, and the consumer protections issues also that Alan mentioned. So the way we're consulting with new early adopters and some of the emerging energy technologies, we'd really like to talk to households who have got batteries or electric vehicles, or are getting pretty close to making that decision and already thinking about how they're going to use them. Also, any households that participated maybe in last summer's demand management programs, there was curb your power, power changes, some of those ones that are asking people to shift their energy use down during the hot weather peak periods. And the way we consult with households is we just arrange a time to come to your house and have an informal chat about the technology you have, how you want to use them, and electricity issues in general. So if you could be willing, once again, to participate in that, feel free to introduce yourself to me or just grab one of these flyers and contact the research team. Thanks.
Thanks, Larissa. Yeah. So we'll take any general questions.
Yeah, I am conscious it's getting late, so I won't feel
Yeah, I think we've got about 10 minutes.
terrible if you leave. But yeah.
Donna and Alan, it's really great what you're talking about tonight. I love the word renew. I think that's really good. I love that you're trying to advocating for people in the community and things like that. But I don't think that is sufficient. And there are two things that I'm pretty worried about at the moment. First is how we perceive the future we will get if we take no action, or if we take standard primary action. The second one is to do with the future that we will get. To some extent, when you talk about SPI Lab, choose an element. Living in Melbourne, think about what the chance will be in Melbourne in 2020, let's say it's another. There's one somewhere on the map that's back where it's now. The people that I thought most very simple Victoria is happening. And because that's a bit further away from the ocean, it's less shocking by the presence of the ocean. And it turns out that forecasting range, if we get 4.5 degrees in warming, then the weather there will be what the weather now is in the Mediterranean. It's parachute. A lot of people don't know what parachute is. They do.
The fin is what it
Flash of rocks and a few trees and a bit of it. Okay? So I reckon we've got to advocate on the lines of what are we going to do if we take no action. Sure, we look at and stuff like that.
Yeah.
But they're all sort of technical. If you take no action, you're going to get parachute.
In fact, there are a few people who've developed computer files that reflect the climate change in each place as well. So I take your point. Maybe one of the things we advocate is, we could say, if you live in Melbourne and you're looking at 2 degrees, look at these kind of climate zones, 4 degrees, look at those climate zones, start thinking about what your house might have to deal with.
Yeah, and it's a hard one because also there's been so much research done about, when we're talking about the fear of climate change, how people just actually go into their shells and don't want to know about it. So it's all about how can we use that without people just going too big, too hard, out of my control, I'm not going to deal with it. And that's why a lot of the thing about comfort and health is being used, and especially it's even been used in trying to get around those echnocrats as well, because if we start using health a bit of a measure, we actually see that we get a bit more movement as well. So I totally understand that. And there's always that thing, the Climate Code Red are doing a really good job on some of the work on that climate emergency, but we also need to do some of that other messaging as well around health and the resilience piece as well, to try and have that conversation with people.
But that's also where tackling people at the time they are going to make a decision that's got long-term consequences for them is an empowering time.
Yeah.
Because it's like, you know, this house is going to be here, even if you're not.
Next question.
I feel very cheated, but I am about to make a decision. And I want to take 30 seconds to pick the time. I want to meet somebody who's built a timber tree. And that may be very easy before we see to use it. And it was in a very high art value. So for anyone who's built a timber tree, put their hand up to you.
Timbercrete.
I read about it.
Yeah.
Good. No.
That's all right.
Hook up.
What? Because you're first up?
I would like to know which is better, a supercapacitor or a battery.
I don't know. I think they have different roles. The supercapacitors seem to be quick response, whereas the batteries are kind of a longer lasting thing. But hey, there's people here who know a lot more than me.
Comment the question. I heard at the moment you lose points to have a non-black roof and to have eaves to the north to protect the glass from sun in summer.
Yep.
Now the question is, one, do you think that's intelligent? Two, on the other side is retrofitting and putting where you've got a slab that's close up with the soil. Is it worthwhile putting the
Insulation.
styrofoam around the perimeter edge?
Yeah. Okay. Right. Well, so the roof thing. One of the reasons why the one thing that's going to come through the 2019 building code is that they're going to require separate summer and winter performance levels. And the reason for that basically is because 6 stars would be illegal in most of the developed world, and you can get 6 stars by making a building that works really well in winter, even if it works worse in summer. Okay, so that's why you come out ahead on balance, because you get more points. Because again, we're dealing with historical weather data as well. So I guess to some extent, the 2019 code, because it will require you to consider summer in a more balanced way, may well shift people away from the dreaded black roof and the concept of eaves. In terms of the slab stuff, that's a very complex question, I believe. I personally think insulating around the edges of a slab makes good sense, because it kind of means you've got the mass of the earth kind of entrapped with your slab. But I don't claim to have done lots of analysis of this. Maybe, has anyone done any field research on this? No, the building sciences people at RMIT could put in a bid for some funding.